In this section, let's learn about writing a given number as the sum of consecutive numbers. For example, one question could be, in how many ways can you write 100 as the sum of consecutive natural numbers? Another question could be, how many arithmetic progressions are there whose sum is equal to 100 where the common difference is equal to 1 and only natural numbers are used, right? So these are one and the same thing. We are trying to write 100 as the sum of consecutive natural numbers, right? All right, let's keep that aside and let's see how we can attempt these type of questions. Now, over here you can see the question is, in how many ways can you do it? It does not ask us to exactly write the ways. So this can be done very fast. If you just want to know how many ways it can be done, the answer is the number of odd factors of the given number. In this case, it's 100 minus 1. So the answer would be the number of odd factors minus 1. That would give you the answer. Now, if you want to find the number of odd factors, you just need to remove 2 and find the number of factors. Say for example, let's take this case where we have 100 as the given number. Now, we know that 100 is equal to 2 square into 5 square, right? If we prime factorize 100, that's 2 square into 5 square. Now, to find the number of odd factors, let's remove 2 and we are just left with 5 square, right? Now, if we just have 5 square, what's the number of factors? It's 2 plus 1, that's equal to 3. So 100 has 3 odd factors. And what are these 3 odd factors of 100? It's 1, 5 and 25. These are the 3 odd factors of 100. Now, over here it's mentioned, after you find the number of odd factors, you need to subtract 1, right? So you have to remove this 1 over here. And why do we do that? As we go on with the method, you will understand why this is done. But at this point, you can remember we are removing 1 because we don't say that one term adds up to that number. So I cannot say that just by writing 100 as 100 adds up to 100, because we don't do that, because we need at least 2 numbers to get an answer to this question where we write the given number as the sum of consecutive numbers. That's why we remove 1. And having removed 1, our answer is 3 minus 1, which is 2 ways, right? So in 2 ways we can write 100 as the sum of consecutive natural numbers. Now let me keep that aside. So we know that this can be done in 2 ways. Now let's try to understand what are these 2 ways. Let's try to see those 2 ways. Now it's mentioned that the sum should be 100, right? So it's an arithmetic progression and the common difference is 1 because these are consecutive numbers, right? Say if 2 terms in an arithmetic progression are 22 and 23, you can see that the common difference is just 1, right? Because 23 and 22 have a difference of 1, right? So when it comes to consecutive numbers, it's an arithmetic progression with common difference 1, and because we know that the sum has to add up to 100, let's write it like this: n by 2 into 2a plus n minus 1 into 1 is equal to 100 because the common difference is 1. Now as a side note, let me quickly write the formula of an arithmetic progression when you want to take sum up to n terms. Now an arithmetic progression can be written as like this: a plus d, a plus 2d, a plus 3d, etc., right? And the nth term is a plus n minus 1 into d, right? This is an example of an arithmetic progression. Now if you want to find the sum up to n terms of an arithmetic progression, the formula is n by 2. That's the n over here, up to n terms. You're finding it up to n terms. You have to do n by 2 into the first term and the nth term. So over here you have a plus the nth term is a plus n minus 1 into d. So this is the formula of finding the sum of the terms of an arithmetic progression up to the nth term. Now we are applying that over here. Over here we know that the common difference is 1. So instead of d, I'm writing 1 over here, and this is n by 2 into a plus a is 2a plus n minus 1 into 1. And we know that the sum of these numbers has to add up to 100. So this is equal to 100. Alright, having established that, let's move forward. Let me make some space over here and we'll move forward. Alright. Now let's simplify this. Let me take this 2 over here in the denominator to the right hand side. So this simplifies as n into 2a plus n minus 1. N into 2a plus n minus 1 is equal to 200, right? Now if you take an even number as the value of n, you will see that 2a plus n minus 1 will be odd, right? For example, say n is equal to 2, 2a will be even, right? 2a plus n minus 1 is what we are analyzing. 2a will be even, n is also taken as an even number, and 1 is odd. So even plus even will give you even, and even minus odd will give you an odd answer. So if n is even, 2a plus n minus 1 will be odd, whatever the value of n. Similarly, if n is taken as an odd number, the value of 2a plus n minus 1 will be even. For example, let's take an example. Say n is equal to 3 and we are trying to analyze 2a plus n minus 1. So in that case, 2a is even, 2a will always be even, n is an odd number and 1 is odd, right? So even plus odd will give you an odd number, and odd minus odd will give you an even number. When you do odd minus odd, you'll always get an even number. Let's take an example. Say you have 7 minus 3. 7 and 3 are odd. 7 minus 3 is equal to 4, which is an even number. Alright, let me summarize. If n is even, 2a plus n minus 1 will be odd. If n is odd, 2a plus n minus 1 is equal to even. Therefore, to proceed, all we have to do is we have to write 200. Right? We have to write 200 as the product of an even and odd number. Alright, now let's try to achieve this. Let's see how we can do this. Let me keep this aside. So we have to write 200 as even into odd, right? Now 200, if you prime factorize 200, you will see that that's equal to 2 cube into 5 square. Now there are two ways in which you can write this as even into odd, and remember that's based on these two ways. You don't need to think of it, but if you want you can think of it and find out, but definitely it will be just two ways. That's what we get over here. So I can write it as 8 into 25 or 5 into 40, right? 8 into 25, I take all the 2's together and I take the 5's together. So that's 8 into 25. Now I can also write it as 5. If I take only 1 5, that would be 5, and everything else together is 40, right? If I take 1 5 over here, I'm left with 1 5 and 3 2's. So that's 8 into 5, which is 40. So these are the two ways in which I can write 200 as even into odd. Now let me take the smaller ones in these two expressions, that's 8 and 5, smaller numbers, and these will help me to find the actual expressions. Now let me divide 100. I'm coming back to 100, right? 100 is the sum that we started with. So let me divide 100 with 5. We'll start with this one over here. So 100 by 5 gives me 20. So let me write 20 over here, and I need 5 numbers. So 2 numbers will be to the right of 20 and 2 numbers will be to the left of 20, or 2 numbers are greater than 20 and 2 are less than 20. So I take the next 2 numbers, that's 21 and 22, and I take the lower 2 numbers, that's 18 and 19. Now if I add these numbers, I will get my answer as 100. So 18 plus 19 plus 20 plus 21 plus 22 is equal to 100. Or this 20 that we got over here is the middle value. Alright, now let's do the same thing with this one over here. 100 by 8 gives me 12.5. Because it's a decimal number, I take the values on both the sides of 12.5. That's 12 and 13. So I have two numbers, 12 and 13. Now over here, because I divided with 8, I need a total of 8 numbers so that I get to 100. I already have 2 numbers and these are my middle values. Therefore, I need to take 3 numbers to the right of 13 and 3 numbers to the left of 12. That is 3 numbers greater than 13 and 3 numbers less than 12. So over here that would be 14, 15, 16, and over here it will be 9, 10 and 11. So if I add these numbers, 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15 plus 16, my sum will be 100. So we have seen two things in this video. The first one is the number of ways in which 100 can be written as the sum of consecutive natural numbers is nothing but the number of odd factors minus 1. And we have seen how to find those actual expressions. Because it's 100 over here, the first step is multiplied with 2, that's 200. You need to write 200 as odd into even. So you can do that in two ways. You can write it as 8 into 25 or 5 into 40, and using this we actually find the numbers that add up to 100. So over here we start with 100 by 5, that gives us 20. 20 is the middle term and we need 5 terms. So we take 2 terms to the right, that's 21 and 22, and 2 terms to the left of 20, that's 18 and 19. So if you add these numbers you will get 100. And for this one over here we do 100 by 8, which is 12.5. Because it's a decimal number, we take 12 and 13, that's the number to the left and right of 12.5. And because over here we have 8, we need a total of 8 numbers. We already have 2, so we take 3 to the right and 3 to the left. So over here we have 14, 15 and 16, and over here we have 9, 10 and 11. So these are the two ways in which we can write 100 as the sum of consecutive natural numbers. In this video, let's learn whether there are any numbers which cannot be written as the sum of consecutive natural numbers. So we have seen that in the case a number is given, if we want to find the number of ways in which it can be written as the sum of consecutive natural numbers, it's nothing but the number of odd factors minus 1, right? Therefore, we can conclude that numbers which cannot be written as the sum of consecutive natural numbers will be numbers that don't have any odd factor. Now, what are those numbers? These are powers of 2, right? Any number which is a perfect power of 2 will not have any odd factor. Let's take an example. Say you have the number 32, which is 2 to the power 5, right? Now, the factors of 32 are all even, right? Except 1, right? And 1, if you write it as 1, again you have to subtract 1 from it, so that would be 0. So other than 1, there is no factor of 32 which is odd. So what are the factors of 32? It's 1, 2, 4, 8, 16 and 32. These are the 6 factors, right? It's 2 to the power 5. So 5 is the power. So 5 plus 1, that is 6. 32 will have 6 factors. And these are the 6 factors. And you can see that except 1, all of these are even factors. Therefore, 32 cannot be written as the sum of consecutive natural numbers. So if you have a question that says find the number among the given numbers which cannot be written as the sum of consecutive numbers, you just have to find which number among the given numbers is a power of 2. That is, it has no other prime factor other than 2. So it's of the form 2 to the power x. These type of numbers cannot be written as the sum of consecutive natural numbers. Let's do this question. In how many ways can 392 be written as the sum of consecutive terms? What are the greatest terms in each way? Alright, pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. Let's do it together. The first step is to prime factorize 392, right? That will give you 2 cube into 7 square. So you have 3 2's over here and 2 7's. So 392 is equal to 2 cube into 7 square. And to find the number of odd factors, right? We know that if to get the answer to this, we need to find the number of odd factors minus 1, right? So to find the number of odd factors, we need to disregard the powers of 2. So you're left with 7 square. The power over here is 2. So 2 plus 1, that's equal to 3. So the number of odd factors is equal to 3. And you have to find 3 minus 1. That's the number of odd factors minus 1. That's equal to 2. So the answer to this section of the question is 2. There are 2 ways in which 392 can be written as the sum of consecutive terms. Alright. Now the next step is we need to multiply 392 with 2, which gives us 784, or that's equal to 2 to the power 4 into 7 square. Over here you can see you have 2 to the power 3. So if you multiply this with 2, you will get 2 to the power 4 into 7 square. Now we need to find the ways in which 784 can be written as odd into even. Now there will be 2 ways. as per what we've got over here, in which you can do that. And these are the two ways, that's 16 into 49 and 7 into 112. Now to get this, you have to just distribute the sevens. Over here I'm taking 1, 7 and everything else together, so this would be an odd number and this is an even number, and up to 2 sevens I can take because I have 2 sevens, right? So over here I'm taking all the 2 sevens in one now factor, so that would be an odd number, and everything else, that's 16, is over here. So these are the two ways in which you can write 784 as odd into even. Now let's start with this one over here, 16 into 49. So let's take the smaller number among these two, which is 16, and 392 by 16 gives you, that's 49 by 2, or it's 24.5, right? Now because this is a decimal number, we need to take the smaller and greater number because we only want natural numbers. So that would be 24 and 25. Now because the denominator over here is 16, there will be 16 terms in this way of writing 392 as the sum of consecutive terms. Now these will be the middle terms. Now already we have 2, so 16 minus 2 is 14. So there will be 7 more terms greater than 25 and 7 terms less than 24. Now in this question we just need to find the greatest term in this set of numbers. So that would be 25 plus 7, which is equal to 32. So that's one of the answers. Now let's take this case, 7 into 112. Let's do 392 divided by 7. We are dividing with 7 because that's the smaller number among 7 and 112. So that gives us 56. Now 56 will be the middle term. Now because we have 7 as our denominator over here, there will be 3 numbers less than 56 and 3 numbers greater than 56. So that will give us a total of 7 numbers, and if you add all of them you will get 392. So we just need to find the greatest term in this sequence of numbers. So that would be 56 plus 3, which is equal to 59. Therefore the answer to this section of the question is 32 and 59.